now we're ready. Sorry.
You're fine. So loop recorders, ours is called the Lux, Lux. That's just the brand name that the company thought was cute to name it. These are little devices. They are literally that small, about a paperclip size, a little bit of thickness to it. It just implants just right under the skin above your heart. What this does is it only is measuring your heart rate. It doesn't affect your heart rate or do anything like that. What it does is it's reading 24/7. What is this heart rate doing? What it does is it's helping the doctor determine, do I need a pacemaker? Do I need a defibrillator? Do I not need that? And it's not actually a heart rate problem, it's something else. Am I having AFib if you've had a stroke and they're not sure why you've had a stroke? That's also why you'll get a loop recorder. What it does is it records 24/7, just watching your heart rate. And these are designed to look for the bad rhythms and stores the bad rhythms inside that device. And that stays inside that little device, has an incredible memory and incredible battery, because that little thing can last for 3 years. So in that 3-year time, they're looking at your data. And then the data is saved inside that little loop recorder. And then it gets sent off to the clinic, all that data every single night. So the clinic can see, am I having okay heart rhythms? Did I have a really fast, bad heart rhythm that needs an ICD? Or am I having a really slow heart rhythm that needs just a pacemaker? So when you get this implanted loop recorder, you're gonna get a monitor. It acts as a little bedside monitor. Either we can put an app on your phone, and your phone is usually, as we are in technology these days, always lives next to us at bedtime. And it will just automatically pull the data and sends it off to the clinic, wirelessly, automatically on its own schedule. If you're like, I don't want an app on my own phone, I have a flip phone, I don't like phones, that's fine. We'll just provide you with a phone. And you'll have a little Boston Scientific phone. That's all it does, is it reads data from your loop recorder and then sends it off to the clinic. Does that make sense on what a loop recorder kind of is? And then the clinic will get, your name will pop up on their screen with a little yellow or red flag, depending how bad your rhythm is. And then they'll call you. They'll say, oh, we saw on Tuesday at 2 p.m. you had XYZ. Are you feeling okay? And then they'll go from there on watching you closer, or just continuing to let that loop recorder do its job. Make sense? There's also a feature on there, say, I want to use this also interactively. So I'm passing out and I want to record that symptom. So I pass out or I feel dizzy. I pull out my little phone and I press a button on here. And that will tell the loop recorder, doesn't matter what my heart rate is doing, even if I have a normal heart rate, you save it. I'm telling you to do an action and save it on top of there. That stores just right inside there as something that you initiated. So the clinic sees it, they say, oh, they felt crummy on this time. Does it correlate with a bad or good heart rate? And they can help determine even more data. This is not mandatory. This is only if the clinic wants you to do this. So I always just kind of say it on the side. And then when the clinic says, okay, we're not picking up these bad rhythms, but you're still feeling symptoms, let's go to this next step. So you can also have a little bit of control in being able to record rhythms at the same time. Not necessary all the time, because that loop recorder is just constantly 100% all day long recording. It's just an extra layer of data. It's a little extra tidbit on there. Does that make sense? Sometimes that gets a little confusing. All right, so we're moving on from our loop recorder. That just only stores and saves data. Then we decide after the loop recorder, what are we gonna get? If we are gonna get a device, we're gonna go through our different categories of what they are. So you know what is what are we talking about here? Whoopsies, oh boy, going crazy. Hang on, go back here. Okay, so we have 3 main categories. There's a lot to read on this slide, but we'll go through them. First one is just a pacemaker. What this does is I have a really low heart rate, 30s, 40s all the time. I'm feeling tired and crummy all the time. The pacemaker will be there just to send a signal down to the heart muscle, then contracts the heart muscle to create a heartbeat. And it's usually set like 60 beats per minute, 70 beats per minute, depending on what you need. So then if your heart rate itself without that pacemaker sits at 30, 40, the pacemaker comes in and initiates that signal to tell your heart, we need a heartbeat here, squeeze, squeeze, squeeze. If your own heart rate goes above our our limit of say 60, 70, it will let your heart rate go high. We're just filling in gaps and making sure that you don't have that really low, sluggish heart rate. Defibrillator is our next category up. So defibrillator can also acts like a pacemaker, where it can make sure your heart rate doesn't go too low. But now, if your heart rate goes too fast, so you have that one of those rhythms, ventricular tachycardia, ventricular fibrillation, that's when the bottom part of the heart is going way faster than the top bottom of the heart. That's the dangerous rhythm. That's the lethal rhythm, because it's going so fast, we're not getting any good blood flow out. And then eventually it'll pass out, and eventually we'll go down the line of cardiac arrest. So the defibrillator acts as, it sees that fast heart rate, that VT, we call it VF for simplicity, sees that really, really fast heart rate, and what they do in the ER where they shock the patient, that's what the defibrillator does, but on the inside. It sends a little wave of shock that goes through the heart muscle, and basically it's like an Etch-a-Sketch, and you just shake the Etch-a-Sketch and it clears out the cells and says, stop that nonsense, go back to your regular rhythm. Because the heart works on an electrical rhythm. So we're talking about the electrical side of the heart with all these rhythms. And it starts going out of whack, basically. You're going too fast in this fast rhythm. We send the defibrillation through, says, nope, stop that rhythm, go back to your normal heart rate. Does that make sense of what a defibrillator does?
Is it successful all the time in making that happen?
Yes, generally yes. You can get multiple shocks. It might not work on the first shock. You might need to get another shock or another shock. There's also, which we'll talk later on another slide, another type of therapy that also helps break the rhythm before the shock. But generally, yes, unless you are so sick, your heart is just kind of refractory, we say, where it will not accept anything, any signal change. Yes, it is successful. It will change direction of shock. It will change the way it's sending the shock through the heart. It'll try different ways. Yep. But generally, it's very successful, unless you're just too sick. And at that point, you're just too sick. But that doesn't happen very often. I rarely see that. The third category there is called a CRT. Now this device is kind of the Cadillac of the devices. It's a pacemaker, it's also a defibrillator, but it also has a third lead. This is for heart failure. And what it does is it tells both the left and the right ventricle, the two bottom chambers of the heart, to squeeze together to make a good squeeze. So if we're having an inefficient squeeze, we're going to heart failure and one's going, the other one's going, and the blood is just not being efficient getting out, leading us into heart failure. This extra third wire, this lead, goes around the left side of heart to make these two, and it fires together to make these two squeeze together on the bottom. Because you start getting out of sync when you start going to heart failure. Yeah?
So I went from a single lead to a 3 lead. So is the 3 lead that?
Yep, 3 leads that. Yep, CRT. And so you might just have a pacemaker still, CRT-P.
Yeah,
Yep.
but we had to turn off one of the leads.
Oh, yeah.
Causing problems.
That will happen too. Yep. So this CRT can be only a pacemaker. We don't need that defibrillator portion, but you need that third wire, that down to the left ventricle, to help your ventricles squeeze together. Or if you also have indication for that VT lethal rhythm, which you probably just don't have any indication for that, so you don't need it. You don't have to have it.
How is that third wire connected to the heart muscle?
Yeah, it's pretty interesting when, so the right ventricle goes inside the right ventricle, down to the apex, the bottom of the heart. And then the left ventricle, we go to the same pathway as that right ventricle, but there is an os it's called, there's a vein. We slide through and we go around the outside of the left ventricle. Mm-hmm. So we go through the coronary sinus. I think I have a picture of it here further down the line. And it wraps around the outside of your heart inside a vein.
Is it just a bare wire then? in touch with the muscle, is that it? Or-
So the leads that we have are, there's wires on the inside, conducting wires, electrodes, all the things on the inside, but then it's wrapped in a coating, like a polyurethane. It's like a spaghetti noodle, so it's super soft. And inside that vein, it just has no screws or anything. It just sits inside of there with a little spiral that sits inside the vein. Yep, it's covered in little polyurethane coating. They're super soft. Here's your pacemaker, that's what it looks like. And then that top clear part is where we plug in the leads. So the pacemaker just sits right here underneath the skin above your heart. And then we access a vein here that then we send those leads down inside the heart. It drops into the right atrium, top right chamber of your heart, and then down to the bottom right chamber of your heart. So these pacemakers can last 8 to 10 years or more. And like I talked about, they generally set your limit, we call it, how low will let your heart rate go, at about 60 beats per minute. All the devices will then also record like that loop recorder does. It's always recording your heart rate. So you can see if you're having a fib, you can see if you are having that dangerous rhythm and need to get upgraded, we call it, like the next category of device. This is an X-ray of what the pacemaker looks like. So you see it there on the left chest. It's always backwards when you look at these X-rays. So that's the left chest there, and those leads are running down into the heart. That red arrow is your top right chamber, your right atrium. The blue arrow is pointing to your right ventricle. That's where that right lead goes down and talks to your bottom ventricle. And then they're attached at that pacemaker at the top. It's waking up. Uh-oh. You might have frozen. And then we'll go to, it likes to jump for us. Your ICD, your defibrillator. You can have single chamber and dual chamber pacemakers and defibrillators. That just means sometimes you don't need help on certain types of rhythms. Defibrillator lasts about 7 to 9 years and does a lot of the same thing as a pacemaker does, but with that extra ability to shock the heart. I'll show you there. It likes to, there we go. So this one, there's that defibrillator, and see the difference of this lead here. There's a thick portion on that lead that's going inside of the heart. I don't know if you probably didn't see that on the other slide, but those are the coils, we call it. That's how the shock comes from that lead and sends it through the heart. It uses a vector. It sends the defibrillation to the can and to the heart. So that we're just encompassing that heart there and then clearing out that electrical impulses that are happening and making it go back to its regular rhythm. And then same thing, it just connects right to that device right on top of your chest here, under the skin. CRTP is what you have in the back there. Same functions as a pacemaker, but with that extra third wire along the left side. And next slide, if it wants to. We'll let it think for a second for you. I get button happy. And then it clicks along. I have pictures of the lead. It's okay, it's just waking up. There we go. And then that device looks a little bit bigger because it's a defibrillator. We have to have our capacitator in there. There's a couple of bigger things inside to be able to send the different shocks and modalities. About the same 7 to 9 year battery. And that's like we talked about. We're going to be forcing those bottom chambers to always squeeze together. So it's always pacing those bottom chambers working together. Gives you really good cardiac output, just helping you move around that blood a lot better. Next slide when it thinks about it. There's that lead that you're asking about that wraps around the left side of the heart. That's what it looks like. So this one, that little spiral in there, that's how it sits and stays inside of the lead. And those little black things on there are called electrodes. That's how then it sends a signal to the heart muscle to be able to tell the cells, time for you to contract, time for you to pace that heart, squeeze the heart. Hopefully you guys can see this okay. So this would be our CRT with our top atrial lead. Then we have the bottom, right, with that defibrillation lead here. And then this lead is where it's snaking around the back side of the heart, outside of a vein out there. Our veins, there's a whole system of cardiac veins on the outside of the heart here that it wraps around and sits around this left side of the heart here. So that's your Cadillac right there, that guy. There's one thing here that you'll learn about if you ever do get a CRT, CRTP, or a D, because that wraps around the left side of the heart here, we have a nerve here called the phrenic nerve. What it does is it innervates the diaphragm. That's there what helps you breathe, gives you hiccups and things like that. Because we're sending electrical stimulus to that side of the heart, and this vein sits right where that heart sits as well, sometimes we can stimulate this nerve, and it will just make your diaphragm jump. It feels like something's kicking you on your side. When patients first get these devices, they think, oh my gosh, I'm dying, something's wrong. My whole side is just thumping, thumping, thumping. But what it is we're just stimulating that phrenic nerve. We're stimulating that, and so that your diaphragm is jumping. I like to tell you guys about this because often it goes kind of unsaid until you feel it. Then you panic about it, and we bring you in the clinic, we're like, you're totally fine. We just press buttons on our little programmer, which changes the settings inside of how the energy is sent and then how it's received inside the heart. So those little electrodes that we saw on the last screen, we can change how the energy flows through the heart to get away from this nerve. This is just in case you get one and you feel that, you're okay, just call the clinic. I try to always educate patients on that. Here's a little side note here. This is also a defibrillator that only Boston Scientific has. This is a device that nothing goes inside the heart. All it does is it's there to shock the heart in case you go into a bad rhythm. That lead there just runs up along the sternum, just underneath the skin. And so nothing's inside, but all it can do is just shock. That's all it does. It just watches your rhythm and sends a little bit of a bigger shock. And it's a little bit of a bigger device because we have to get through bones and skin instead of being right inside of your heart. So that's a little guy there. Not seen as often around here. Some places implant them a ton. They've been on the market forever. But a little caveat that we have. It's a nice option if you can't have anything inside the heart. This is still have availability. Yep, it's on the outside. Okay, that was a lot. Any questions on that? Yes.
If you have sleep apnea, they have devices now that attack that phrenic nerve.
Yep, exactly.
Can you have both for central sleep apnea? They use something called a remedy, and
Yep.
something else for the obstructive sleep apnea.
Yeah.
Either one of those affect how one of these pacemakers or?
No, we have had, so Dr. Decker, we work with him a lot. He implants some of those. And we have had patients with our devices and they implant that and they haven't seen any interaction. Yeah, so you should be fine. They'll do a little test to make sure during the procedure. I was in on one. I was connected to the device and the other rep was there putting in the remedy, the sleep apnea device. And while she was testing it, I was looking on my screen to see if my device was picking up those impulses. And it didn't. Didn't see a thing. So, worked fine. Yeah, we call those concomitant devices. So, you can have multiple devices and they won't interact all the time, but you do always want to check to make sure. Yep, good question. So same thing as how does that data get, there's so much data stored inside these devices constantly, same as that loop recorder we talked about. It's storing rhythms, it's storing how much am I in this one heart rate, am I having bad heart rates, how are those leads looking inside of my heart. They need to also get to the clinic. So we provide you with this little box, it's about this big. It's called the latitude monitor, it's just a bedside monitor, it sits next to you, you just plug it in and kind of forget about it. It will automatically and wirelessly connect to your device, pulls off the data on its own schedule, ships it off to the clinic. You don't even know what's happening. That way the clinic can review the data. They'll be able to be alerted if, say, one of your leads is starting to go bad, like we had in the back. They'll be able to see these numbers that are changing, that we're measuring, and so they can call you and say, hey, we need to bring you in, let's look at that. Or, hey, I can't get into the clinic for a while, can you see my data online and make sure everything's looking okay? There's also a way for you to send in transmissions to the clinic if you're feeling real crummy and you think it's your device. So this is a great tool that everyone just gets. It just comes, it's a package deal. Everyone gets one of these. There's a little app that some patients like, other patients say, too much technology, I don't like it. Family members like it, sometimes kids like to download this. This is an app that connects to that little white monitor. What it does is it tells you, what's the battery life? My battery life okay of my device? Is that monitor working, sending data properly? And then when is the next time the data is sent? So I'm in the know of what's going on. Also does troubleshooting, things like that. That's just a little extra thing that a lot of family members like to download it so they can keep watch on you.
Can you see any of the data? Can it show any of the data?
No, it's my number one question. Yeah, less is more, they thought, so they don't show you anything. All they'll tell you is if your battery is good. As far as data. It will also tell you if the monitoring's working, things like that. But as far as seeing any data from your device, you don't get to see it on that. I know, that's a bummer. They always ask me about that loop recorder too. It could be fun if you could at least see a little bit. I would let you see a little bit. All right, interrogated. I've said this word a lot. What it means for a loop recorder, as a nurse or a rep, we have our own phones. It's a little white one. And we just wave it real close right on top of your loop recorder. What it's doing is it's connecting and pulling any data stored at that moment and sending it off to our site so that we can read all your data right there. They often do that in the ER because the ER doctor says, well, what if something was stored that caused them to come to the ER? And then you'll go routinely into the clinic so they can pull your data and just check up on you. So loop recorder, pretty simple. Pull the data, read the data, that's it. Does that make sense on that guy? He's pretty straightforward. We like loop recorders. All right, whoopsies, go back there. If we are interrogating your pacemaker or your defibrillator, your CRT, we have this little machine here, this little blue guy. You'll start recognizing your company. Each company has a different color, each company has a different machine. And so if I walk in, you're like, oh no, I have an Abbott device. I'm like, sorry, I walk out because we need the Abbott rep. Everyone is very specific to their only company. A nurse clinic, they have all the programmers there, so if it's a nurse doing it, they'll just pull up the other programmer, we call these things, and then they'll connect you with this little guy is a wand, we call it. This we just place right on top of your device and it connects and pulls up all of your data, everything we could possibly change, the settings, all of those readings, I can see right on that screen. And that's where I can click all those buttons to change things. Back up. Something we do every single time in the clinic, we call testing your leads. Anybody know what that means?
Make sure they're still connected.
Yes,
Yeah.
Yep, exactly. Making sure they're still connected to the heart properly. Over time, it's the body, things are moving, it's still a mechanical thing, so little fractures can happen, little dislodgements might happen, who knows? I've seen a million different things, but it's all can be adjusted within the device as well. It's not an end-all be-all situation. And some will have these leads for 20 years and not have one issue. It's your anatomy, it's the placement, luck of the draw, to be honest. That's why we always are testing these leads every single time you come in. We don't want to leave you out there thinking, I don't know if it's working properly or not. So we do 3 main tests on these leads. One is how well is that pacemaker defibrillator lead seeing my heart rate? When you see a little EKG, it's looking at that electrically on the inside. So it'll show us, is it seeing that heart rate? It has a little measurement. If it's really, really little, it's like 0.1, we're like, that's pretty small. 2 millivolts we're talking about, 5 millivolts. These are all numbers. We work a lot on numbers, and when you hear us in the clinic, we talk in a lot of milliseconds, millivolts, volts. Basically, is a pacemaker seeing your heart rate properly or not? Second one is we're sending energy down a line, which will have impedance. So that's just the resistance. How hard is it for the pacemaker, the defibrillator, to send that energy down to your heart to be able to stimulate your heart cells. There's a kink in a hose, right? So it's really hard for any water to get out of that hose. That would be an issue. So same thing, if there's a big kink in your lead, we'll see a big higher number, we're like something's wrong. So we use that to tell your lead's looking okay. The last thing that's also very important is then we say, okay, we're gonna test your lead now, we're gonna raise your heart rate, and we're gonna force the pacemaker to pace your heart while you're sitting there. We might send you you'll be sitting there and going 90 beats per minute, and you think you're going for a little run while you're just sitting there. Some patients don't feel it at all. I'll always tell you, hey, I'm gonna start this, you might feel this, it's uncomfortable, stop. Some patients, majority, I'd probably say 80% don't even feel it. You don't even know that I'm changing your heart rate, you're just hanging out. What I'm doing is I'm forcing the pacemaker to pace your heart above your own heart rate so I'm in control. And then I'm decrementing down how much energy does it take this pacemaker to make your cells of your heart contract. So, say it's 1 volt and I go to 0.9 volts, all of a sudden your heart doesn't like the signal and won't squeeze. I go back up to 1 volt and it will squeeze. So that's, we call that the threshold, how much energy is needed. So, those 3 tests we're always looking at. That's what they're doing on that program when we're over there poking around all the time. And we're also reading different data, looking at your heart rates, and making sure that everything is working okay for you. Those tests make any sense?
Mm-hmm.
One portion of them at least. At least you have an idea of what they're doing on that program or when they're connected to you. We're also looking at your battery, which is also a big question. This is literally a picture of what it looks like on our programmer. It looks like a little gas gauge. I tell them, hey, it looks full. That yellow part is like your gas light coming on. Be like, hey, you got some time left, but you're getting close. Don't be running this to the ground. They'll start watching you a little bit closer. Yes?
There's one thing you need to tell people.
Yes.
Because when the battery goes out, it beeps.
Oh, the ICD beeps.
Yeah, and it
Yes.
gets longer and more often in frequency when that happens.
Yes, so if you have a defibrillator, when you hit this indicator, that explant down to that red bottom, that's when you have 3 months of full functionality, full power of your device. But in those 3 months, that's when we want to get you scheduled to get a battery change out. Because we don't want you to go 4, 5, 6 months and all of a sudden we're like, oh, we can't guarantee it's going to work 100%. And a defibrillator, because we'll be watching those rhythms to shock you out of a life-saving event, your device will beep. Once a day, 12 beeps, same time. And you're gonna be like, what is that? A lot of patients think it's their smoke detector, or it's some kind of machine or something, and they're like, what is that? I'm like, oh, I've been hearing a beeping. I'm like, oh, that's your device. So it's an alarm to you to know, oh gosh, my device is getting low, I don't wanna run my battery to the ground. These battery life is also seen through those home monitors, so they're always watching that. And then you have that 3 months time span to come in and get a new battery. And that's a much simpler procedure. You just come in, we make sure those leads look good through those tests. If everything looks good, we just open up, unplug, get rid of that old one, plug in a brand new one, and then send you home that same day. When you first get implanted, it's a little bit longer procedure. You'll have arm restrictions. You can't raise your arm over your shoulder for 4 weeks while everything's healing. So the battery change out, all you have to do is take care of your wound and you're good to go.
I heard, and I may be wrong because it wasn't from one of the techs or the doctors, that they have to replace the pacemaker. Do they replace the pacemaker or just the battery in the pacemaker?
Yep, good question. Very common question. You'll replace the whole unit.
Okay.
Yep, it's all encased, titanium cover. Nothing can get in or out of there. And so we get rid of that whole one and give you a brand new one. Yep.
Is that the same with the defibrillator?
Yep, every single one. Yep.
Is it like an outpatient procedure? I mean, you're opening the skin back up to get to these devices.
Correct, yes. Outpatient on your battery change. If you're getting is it your first time implant, you'll stay the night, generally, depending on the hospital and the physician. Some places you will still be an outpatient scenario. You'll just stay in a little bit longer in recovery till they kick you out. You'll go home with a sling and those arm restrictions. Thing is, we don't want, because it just is entered right here under the skin by this muscle, we don't want you using your arm a lot, no carrying anything above 10 pounds, no lifting your arms too high, because you're gonna be using that muscle and pulling back on those leads, and you could pull them back out. And then we have to start all over again. So about 4 weeks is how long it takes for everything to heal down, kind of get little scar tissue. It acts like the glue to make sure that things don't get pulled back out of your heart. But as a battery change, they've already been scarred down there for years and years and years. So you can walk out flapping your wings if you want, it's just gonna hurt.
I was told that when I got my pacemaker that I couldn't wash dishes for 5 years.
Yeah, make sure that's written down. Yeah, I get a lot of questions like that. Oh yeah, you can't vacuum for a long time.
Do you ever have a case where a patient's body will reject any part of the, the placement underneath the skin?
Yeah, very rare, very rare. Sometimes some kind of metal allergies come into play. That wouldn't necessarily be with the pacemaker itself, but the leads have some, oh gosh, it's my baby brain. It'll come to me. Nickel. So if you have a nickel allergy, like extreme nickel allergy, there is potential for contact with the blood. And so in that point, we'd use a different type of lead that doesn't have any kind of nickel. So we just want to know that beforehand. But the, called a box sometimes, the pacemaker, defibrillator itself, it's titanium, obviously surgical grade. And so, and with some silicone polyurethane, but it's generally the lead with a nickel. But there is a way around that, yeah. There was one patient, gosh, it was years ago, that they had some crazy allergy and was rejecting hips, rejecting knees, rejecting all sorts of things, but really, really, really needed this device. And Medtronic is the only company out of all the companies, they make a gold-plated pacemaker. This patient got a gold, I was like, what? I didn't get to be there because it wasn't my company, but yeah, so they got a gold pacemaker. I'm like, whew, that's fancy. So yeah, it doesn't happen. That was once in 10 years. And that's never happened. And my colleague I work with, Zig, he's been doing this for 30 years, and he's like, I've never seen that before. So very rare. But yes, nickel is the biggest offender.
Question?
Oh, I'm sorry.
So I have a mechanical valve on my main aorta.
Okay.
If I ever had to have a pacemaker,
Yep.
would that interfere with the mechanical valve?
Very good
It's
question.
titanium and
Yep.
it's clicking away.
Yeah,
Heartbeat.
doing your thing? Good. No, not at all. You can 100% get a pacemaker, no problem, because the leads are going through your other valve, the tricuspid valve.
Okay.
So we're on that's on the left side of the heart. We're only working on the right side of the heart. So only through the low, oh gosh, not the low power. The lower, oh my brain, this baby's killing me. Pressure, the lower pressure side of the heart. So is the right side of the heart. And so that's where we have all of our stuff. So if you have an aortic, won't even touch it. Yep,
Okay.
no problem. Yeah, good question. Common questions here. We're talking about the battery replacement process. Does that make sense to everybody on how that works? Then you get a brand new one and you're good for another 10 years. Airport security and traveling. People always ask me about this, and I always tell them in my discharge education. Everyone gets a medical ID card with all the devices. You'll get a plastic one sent to the mail in about a couple months or so. Always keep that in your wallet. But airports, when you go through, they see a ton of devices. So you just say, before you go through, just tell your TSA agent that's on the line, or before you go through the scanner, like, hey, I've got a pacemaker. Follow their protocol. Sometimes they'll have you just go right through with your arms up. Sometimes they'll come through and just re-wand you just to confirm it's right there. The scanners don't hurt your pacemaker. They don't affect anything. It's just more of their protocol to be able to scan it to make sure it's not something else. So no problem there. MRIs, all the new devices are 100% MRI compatible. You just go in and we'll come in and we just do a special programming before your MRI. Depends on the types of leads you have. There's different restrictions on if you can get an MRI, if you have any leads that we had to abandon, we call, so you have a broken lead, so we're gonna unplug that one, just leave it there and give you a brand new lead to replace it, but it's still hanging out inside your body, no MRI. But if you have them all plugged into that pacemaker, you're fine. So there's a lot of fine line things, but brand new devices that we're getting now, no problem in MRIs. They'll just talk to your doctor, they'll confirm with us, they'll look at all your data, they'll talk to the MRI guys, and they'll make it happen. So you could still get one. CAT scans, x-rays, all those other things, doesn't matter, go ahead and at will. MRIs get a little confusing, but you still can get an MRI. There's just some extra hoops. Oh. Everyone asked me about microwaves. No problem on microwaves. Now newer ones, of course, are lower power, more protected, things like that. I always say just for your general health, probably don't lay on a microwave anyways. But distance is your friend, arm's length away from anything you're unsure of. Generators, we have people that weld, we have people that work on cars, we have people that do all sorts of things, but just distance is your friend. Just don't lay things right on top of your pacemaker or device, like a phone, things like that. ER, we kind of mentioned that. That is when they come in and we'll bring that little programmer over and read all your data and it uploads so that the doctors can look at it. You don't really have to do anything. They'll just ask if you have one. You gotta make sure you know your company. So they grab the right machine and call the right person. Other than that, you just let them know what you have. Other surgeries and things, like we asked about, like Remedy and things like that. If you go in and get your knee done, they'll always check to make sure this is working okay, and the anesthesiologist is always watching your heart rate to make sure that things are looking good.
There used to be a restriction against, you know, the new stovetops that are induction.
Mm-hmm.
Is that still in place, or?
Nope, you're good. Yep. These ones have a lot of extra layers of insulation and protection. They're well suited. So, yep, no problem. Yeah. Any other questions of anything about devices?
So, are you a separate entity from the doctor-patient relationship?
Yeah, in a way.
So,
Yep.
So all that reporting goes to a Boston Scientific, if it's your instrument, and then you communicate with the doctor. Is that how that works?
Yeah, that's a really good question.
Or
Yeah.
are you embedded in with the doctor?
Yeah, really good question. We do work very intimately together on all fronts, from the implant to follow-up in the clinics and everything. Our data gets uploaded, and same with all companies. The data gets uploaded to our server. We have access to it, and the doctors have access to it. So the doctors and the nurses will be pulling it'll go straight to their clinic specifically, so then they can pull it up and look at it. And then if they have a question that they can't figure out, that they need more expertise on it, they'll call us and we'll just look it up from our side.
So what about charges for that?
Yeah.
Not electrical charges, but charges.
Yeah, talking electrical things. Yes, so that will, I'm not super privy on like dollar amounts. There is you'll have clinic follow-ups, and you'll have those remote, we call them those remote follow-ups from that home monitor where they're reading it, but you're skipping a clinic visit with that reading of that monitor.
So would that be your clinic or?
The doctor's clinic,
The
yep.
doctor's clinic.
I don't have a clinic.
I got it.
I float and go everywhere that they need me.
Okay.
And so, yeah, so it would be coming from the doctor, not from us. Yeah,
I
all
have
those,
one more.
yeah,
So the leads,
Yeah.
placement of the leads.
yep.
Did you say that none of them attach directly to the heart, or just the one?
Just that one specific one, yeah, I should have done a little video
So
on that.
So when
Yeah.
when they are attached to the heart,
Yeah.
what's the process to get that from the
Yeah.
Under the skin? How do they?
Right.
How do they place it?
So what they do, yeah, so they'll open up, we call it making a pocket. So we make an incision here, we'll make a little area for the device to sit. They then take a needle, an access needle, that then will puncture the left subclavian vein. So it's a vein that just runs right here. That vein then runs and then dumps into the superior vena cava, which then, that's just a big tube that goes into your right ventricle, the top right chamber of your heart. So then what we have, so they put a little wire, and then on top of that wire they put a sheath. They take that wire out, and that sheath is like a little straw, has an opening, and then we just feed the lead down the straw. And then that little straw stays there, and while the doctor is pushing this lead down, it drops down into the heart. And then we have little metal stylets, we call them, little metal wires that are bent a very specific way. This go right in the right place inside the heart, and the doctor is going to be moving it to find the right position. And then there's a little helix. It's a little tiny screw that comes out that attaches to the muscle of the heart. And that's where it holds inside the heart. So the top right chamber and the bottom right chamber have this little screw that holds it in. It's pretty delicate, so that's why we have those arm restrictions and waiting for things to heal. I think on this picture you might be able to see it.
Leah, do they use imaging?
Yes.
To do their traversing
Yes.
and placement?
Yep, we call it fluoroscopy. It's live x-ray. So you'll be laying on the table and this big machine's gonna come over you. And they step on the pedal and it pops up, and it's live. We can see things moving. As it looks like an x-ray to the eye, but it's live. So you can see your heart beating, we can see the thing moving, and then we're staying there next to the doctor and we're testing it. Once they place it next to the end of the heart, we're testing those 3 tests that I talked about that we do in the clinic to make sure it's in a good spot in the heart. Sometimes there's scarring, sometimes there's different tissue we don't like, so then he'll unscrew it, move the little wire so it moves a little different area, and stick it in a different place in the heart, and then screws it back into the heart. I'm trying to find a picture where it shows a good, one of them had a pretty good, we could probably leave this one up too and you can come up and look at it. This end here, that's the little helix, the little screw that goes into the muscle at the end of this lead. Does that make sense? Yeah, and then that little, so the little straw then gets peeled away, and then it's just the leads is sitting right inside of the vein here, and then can't really see on this picture, but then they suture it down with these little sleeves that protect the lead from the suture. They just suture it down to the muscle right here.
So then, there's a representative from Boston Scientific in the room when that surgery procedure's going on.
Yep, yep. We're in all the implants. We bring all the goodies, and then we drop it on the sterile table. We open up the that little straw sheath thing, and we open up different instruments, and then we bring the actual product, the pacemakers and leads, and we drop those on the table, on the sterile table. And then they have a scrub that's there doing all of their things with all of the instruments. And then we're there chatting with the doctor and hanging out and testing things and making sure it's all. And then once it's plugged in, we have our programmer that's there, and we're testing it from there again before they close you up to make sure everything's connected properly, it's working good. He's like, hey, how fast do you want this person's heart rate to be set? And the doctor tells me, and then I program it, I set it. So yeah, we work very closely together.
So you're covering all bases, you're really covering
Yeah.
every stone turning, every
We
stone.
float everywhere.
Yeah.
Yep, yep, anywhere that needs us.
The third lead that goes on the outside of the heart, how does that get to the outside of the heart?
Yeah, it's pretty cool. So inside, it's a little difficult to see. Inside your top right chamber of your atrium is called the coronary sinus. There's a little vein that dumps blood into that chamber from that side of the heart. And so then we're kind of going, scooting through that little hole, that vein, and then shooting the lead out that direction. And then there's specific, those straws, it's a very specific shape and has a, different shapes to be able to find that little opening. And it often is very difficult because everyone's anatomy is different, stretched out. Often you have AFib, which makes your atriums bigger and kind of, we don't know, it's not a straight shot every time. So these devices take a lot longer to implant or can be a lot more complicated. Pacemaker, we can get done in 30 minutes. Defib, 30 minutes. Sometimes these can take 4 hours because we're trying forever to find that one little opening in that right atrium. That's tiny. And there's valves across it, and then you're in AFib, and the swishing the little straw around all over the place. So yeah, those ones get a little complicated. And then there's the same little type of wire that then helps that lead track, we call it, just follows the vein. Does that make sense?
Yes, thank you.
Yeah, yeah. Yeah, they're pretty.
How do the loop recorders and the pacemakers differ considerably, I'm sure, because of the cost? My watch can tell what my
Your
heart rate.
heart rate?
and all that
Yeah.
stuff. Is that as accurate or near as accurate? I mean, it does an EKG theoretically.
Your
but-
watch, yeah, yeah. It is, I say I take it plus or minus 10 beats. Generally speaking. They're getting a lot better. I've had some guys be like, all right, they have a watch on, they're looking at their heart rate, and I'm looking at their pacemaker, and it's pretty dang close. Different variables, say like PVCs, those early contractions that happen in the bottom chamber of your heart, those don't have a good squeeze of blood out, so it doesn't also always get seen by the watch. So we get a lot of calls, be like, oh my gosh, I think my heart rate's 30 beats per minute, but it's really 60 because every other beat is this little quick beat. That's just not squishing out blood forcefully enough. So a device implanted would be 100% accurate. Your watch would probably, I don't know, depends on how fancy and like the perfect, if you're holding it perfectly, there's no sweat, different things like that. But it's a very good tool. I always tell patients, use your watches if you would like. It's always good to use your watches because then you have an idea. You have a range of what your normal is. Granted, it might be 5 beats or a couple beats off, but you still know, hey, if I'm always sitting at 50 to 60 and then all of a sudden I'm sitting at 20, you know there's a problem. So I say a watch is still a really good tool to use. And to be able to see the EKG as well is really cool.
Are those EKGs fairly accurate too? Not as far as distances, but
Yeah.
just the shape of.
Just to see, like in general, I think so. I haven't practiced with it on myself a lot, so I don't have a lot of my own experience on it. Just from what patients have shown me, I've seen, and some of them are pretty good. Yeah, like I wouldn't use them to like measure or anything, but to get a general idea, which I always think is still a really good tool. So that you have an idea, like my heart rate usually always looks like this, but then I feel crummy and it looks like this. You know there's something going on. And I've had patients come in and been like, see here, this is what it's doing. And I'm like, yep, it's doing that inside too. So you're not crazy. It actually is seeing a difference. So I would say using your watch is really good. Figure out what your normal is. And if there's something that's not normal, then that's a cause for a call. Yeah, I think it's a good tool. But 100% accuracy is a device, but hopefully you don't have to go
A watch
to.
and a pacemaker, you rely on your pacemaker.
Yeah. But you can still use the watch just to make sure that thing's working right. Yeah, yep. Good question.
You spoke about rhythms. I wrote down 8 of them here, and then you spoke about bad rhythms. So I know, a normal heartbeat would be a normal heartbeat. So out of that group, are all those bad rhythms, or is there some, of course, worse than others, I would assume?
Okay, you might have gotten it from, I listed. There's some rhythms there. Yes, so good rhythms, we call it normal sinus rhythm.
Yes.
Everyone has different levels of how bad is the bad rhythm. Some people can have, so we have different categories. Let's see. So you have categories from the top chambers and categories from the bottom chambers. Your top chambers would be like AFib, atrial fibrillation, A-flutter, atrial flutter. Those rhythms can be dangerous if you're not on blood thinners because they can create clots. But they're not going to cause you to go into like a cardiac arrest where you'll die from a bad heart rate. You also have things coming from the bottom, also from the top, bradycardia. That's brady means slow, cardia
Yes.
heart, so slow heart. So you're having a slow heart rate in those 40s, 50s. And if you have symptoms with them, then you can qualify for a pacemaker. You have, is this answering your question?
It's going there.
Okay. I wasn't sure if I want to start like blabbing about every rhythm, or do you have a specific, I don't know if I missed your.
Brady, because I had,
Yeah.
I had basically, I don't wanna take up your time, but
You're fine.
there was a monitor placed here, and I'm very allergic to adhesives.
Yeah.
So that just went like,
Yep.
I didn't wear it for 5 days.
Yeah.
And it was a mess, but that's,
Yeah.
my decision, like, they wanted me to have it for at least a couple weeks, and I said, I can't do that.
Yeah,
So
those are
I
hard.
said 3, and then I thought, hey, Mary, you're a big girl, you could do 2
You
more
can do
days.
2 more days.
So, yeah.
Deal with the
When I
rash
had,
later.
When I had my heart attack, a supraventricular tachycardia
Okay.
was the big, and I think there was an AFib. AFib has not shown up. If I'm overstepping what you wanna answer, that's fine.
No, I can answer whatever. You just
But
take it, it's not medical
the
advice.
Brady, cause they recorded the Brady, and I know, I can tell physically, mentally,
Yeah.
my heart is off,
Yeah.
not just the feel. I can tell my
Yeah,
body's
just feel
telling me
drained,
it is.
yeah.
But the Brady kind of threw me for a loop because I never thought about that. They came in like 32 or 34, and I'm going, holy moly.
Yeah.
Are we just wearing out here?
Yeah,
And then, I was approached about, unfortunate to me anyways, the whole pacemaker thing was like, here's why you're here. And then it backed up into loop recorders, and that was just a whole new dance for me to think about. stuff.
Yeah,
But
yeah.
that makes sense to me, but it's like, I noticed basically, and I know this isn't like a doctor and patient relationship.
Very fine.
But, in the morning, it's like, that's when everything's wacky. I mean, I'm stretched out, I'm comfortable, I'm warm, I'm sleeping.
right.
But during the day, I seem to be cooking along, and even in the morning, when it's right, it comes in at, 60,
Yep.
which is down here, but 60's good to
60's
me.
good. Yep,
It's
60's
not
good.
like I'm racing around or anything.
There's also, there's another rhythm, I didn't write it up there. Is heart block. We wanna talk to you about heart blocks. So heart blocks are a really big rhythm that gets, flagged as say, normally your heart rate's at 60, but then all of a sudden my heart rate's at 30, it's like half. What's going on? So a heart block, what happens is it's a very common rhythm, and it can happen to anyone. We have 30-year-olds that have it, you have 80-year-olds that have it, you have some that never get it. It's kind of a thickly little guy. So what happens with the heart, we have the sinus node. So that's in the top right chamber of the heart, and that little guy drives your heart rate. It says, you're walking around, I'm gonna make your heart rate go faster or slower. It sends a signal. That signal travels down these branches that go from the top, tells the tops to squeeze, goes through this little intersection here, the AV node, to talk to the bottom ventricles down here. So I send the signal, we tell the top to squeeze good. All right, signal's going down these channels, we pass this junction here, then the branches down to the ventricles down the bottom. That says, all right, you guys, your turn, squeeze. So this is what we normally want to happen. Top, bottom, signal, travels freely from the top to the bottom. Normal heart rate. What can happen, so if it's just bradycardia, slow heart rate, this guy up here is just going slow. He's sending a signal too slow, and it's transferring down, and he's like, okay. But it's going normally, just too slow. The block, this guy is going, oh, I wanna go 60. Sending my signal, these guys are squeezing. I'm hitting this junction, and this junction's frying out. It's not transferring, it's blocked. The signal's coming here, and only half of them are getting to the bottom, or only partial are getting to the bottom. So this guy's saying, I'm firing away, but it's getting blocked. And this guy's only going once in a while. So that can happen where, that's where you all say, oh, I'm in a 30 beats per minute heart rate. It's generally that, because your top one's trying to send it. This junction has a lot of issues with a lot of people. Very, 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 very common. This junction just cannot translate the information from the top to the bottom. So your bottom just starts going really slow. there's little backup pacemakers inside their own heart. Because if this block is complete, that this block says, nope, I am not communicating from the top to the bottom anymore. There's little backups for your heart. It's pretty incredible. Your heart rate can help drive itself. The bottom ones will help drive themselves without the help of this top guy. But it can't go on like that forever. It's just kind of like your little backup till we can get some help. Does that make sense on heart block? Then there's different categories within that, which I'm not gonna get into, but it's basically the signal from the top is not reaching the bottom, and it's because of this little middle guy that's having the issue. And that's why you have those two leads inside that with the pacemaker. You have that lead in the top to see how fast we wanna go. The lead in the bottom, make sure the bottom gets the signal. The top goes, and the bottom's waiting, says, hey, am I getting that signal? Nope, okay. I'm telling it to go. Keep everything, one beat here gets one beat down here. Does that make sense?
Does that mean if you have a pacemaker, you're not gonna have that heart block?
Potentially, yeah.
Potentially.
Yep. There's a lot of other reasons why you get a pacemaker. That's just one of them. Yep. Because you could have that bradycardia where the signal's still going fine, it's just going too slow. It's just too sluggish. So we need to pep it up a little bit. Then your pacemaker probably is only telling your top part to fire, and because it can send it on the rest just fine. That bottom lead's just sitting there, just watching, not doing anything. Except watching. Yeah. Loop recorder before you get the pacemaker is probably because they need proof of
Yes.
that rhythm / specific symptoms that go with the rhythm to qualify for insurance purposes.
So, this is a tie-in question, Liz. So if one of the medical people that one was seeing says, yes, loop recorder, yes, pacemaker, yes. And then you do consult somebody else who's well-known and a good medical doctor, heart doctor. And let's just say that person would say, it's not all unusual as one ages to have a variety of different heartbeats. And doesn't think you really need pacemaker because you've got a variety packet here, because the heart is now pushing 83, so.
Yeah. I see both sides. I would say, yes, that one might be because they're not sure which rhythm they wanna focus on. Say which device would best help you. Cause sometimes you don't need a pacemaker, you need the defibrillator. Sometimes you don't need that defibrillator, you need the one with the 3 wires, but not quite yet. Or maybe a whole nother side, which is part of my company as well, but it's a whole different world, is ablations. That's a whole nother
Yes,
few-hour conversation.
yes.
But, yeah, I'm always pro loop recorder because it will see it, you can record your symptoms, you can note everything, you have
Yes.
proof, and then you can go from there if that's available to you or a part of your care plan. It's always nice to see them before you get the device. I always hate when patients jump straight to a device and all of a sudden they're only paced like under 1% for 5 years, and you're like, do I even need this? But everyone is different on that. Sometimes you get a pacemaker and you do only use it once in a while, but when you need it, you really need it, so. Varies, yeah.
Does a loop recorder, are they different loop recorders made by different companies?
They are.
Completely different? I had my first loop recorder after I had an ablation.
Yep, that's very common.
And so that is common to
Yep.
do that.
Yeah, very. Yeah, cause they will, and, your 2-part question would be, yeah, company to company, everyone has different devices. And we all have our different little specs that we like to push. Say ours is better because of this, ours is better because of that, but at the end of the day, it does the exact same thing. So if you go somewhere and it uses one thing versus another, you don't have to worry so much about loop recorders, they're all pretty stock standard. Ours do, for a little plug, ours do have the really good, tracings, really, really clear. But a loop recorder after ablation is very common because they want to see if the ablation worked. Or if they did just one ablation, which is a burning of the heart to change your rhythms. because I did that burn, are there different rhythms appearing that we need to address? So it's very common, or if you did an AFib ablation, they want to make sure you're not having any AFib before they take out the thinners. So it's kind of like a safe gate there. So yeah, very common, all the time, we're popping those things in like popcorn.
How long has the liquid quarter been out there?
Oh, long time. Long time, yeah,
That's a long
I
time.
don't know, probably, I mean, 10 plus years, 10
10
some
plus
years, yeah.
years. Thank
But
you.
they're now getting smaller and smaller and smaller and smarter and smarter and smarter.
Yes, yes, yes.
But, yeah,
Thank you.
yeah.
Any other questions for Leah? If not, let's thank her for a
Lots-
wonderful.
lots to go over. Yeah. There's lots to talk about, so we could talk